We're now going to take a look at the different types of boiling modes that can exist. So in the last segment, what we did is we looked at water boiling on top of on a stovetop, and essentially what we were watching there was pool boiling because we were not forcing the fluid in any way. If you recall, at the beginning, the process started with natural convection. So pool boiling is one mode of boiling that can exist, or that we can have. So pool boiling, that is where we have a quiescent fluid, very much like what we had on the stovetop with what we just looked at. And what happens there, so there's our liquid interface, we have bubbles forming, and as a bubble lifts off, what it does is it entrains fluid behind it, and so there'd be an entrainment mechanism as the bubble is moving up, and that entrainment process enhances mixing that is occurring, and so that provides a mechanism of free convection and mixing that we have going on within pool boiling. So that is one form of boiling. Another one is where we have forced convection. So where we, let's say, have a pipe within a boiler and we're pumping a liquid through it and it is going through a phase change process. So that would be forced convection boiling. So forced convection boiling is rather complex, and it's going to vary dependent upon if your pipes are vertical and you have the fluid going vertically or if they're horizontal. And what happens is we go through a phase change, and so this is referred to as being two-phase flow. And the fluid mechanics here are quite complex, and we won't spend a lot of time, well, we won't spend any time looking at it. But the process here, we have the forced convective heat transfer going on. We can have free convection because we'll have temperature gradients and mixing associated with that. But bubbles themselves, they have wakes behind them, just like we saw cylinders and the flow behind cylinders. Well, bubbles the exact same way, and as they're moving, you can have slip. They could be moving at the free stream velocity, the local bulk velocity. They may be moving slower. They might be moving faster if they get caught in an eddy. So the fluid mechanics here become very, very complex. But anyways, that is forced convection boiling. Now, boiling can also be classified as, so we can either have pool boiling or forced convection. We just looked at that. But boiling can also be classified dependent upon the temperature of the fluid or the liquid. So we can have subcooled, and this is where our surface is above the saturation temperature, but the liquid itself is below the saturation temperature. So subcooled boiling, we saw this in the previous segment where bubbles were starting to form, and as they were ascending, what was happening is the fluid was cooler than the bubble temperature. So we have vapor inside of the bubble, and due to heat transfer across the bubble wall, so that vapor would be losing thermal energy. We have a very delicate balance with the bubble, but essentially what would happen is the bubble would get smaller, and then you could see in the video clip it would just disappear. And that was because the liquid temperature was not high enough in order to sustain the bubble growth as it moved upwards. And so that is what was going on there. And that is subcooled boiling, where we do have localized boiling down at the surface at these nucleation sites, but the bubbles don't have enough to make it all the way to the top, and so we're not getting that much vapor coming out. The other type is saturated pool boiling, or it could be saturated forced convection boiling as well. But we usually look at pool boiling as what we're going to be talking about. And here, the temperature of the liquid equals the saturation temperature. And so when we have saturated boiling, I'll look at the case of pool boiling again. So we have our free surface. Our bubbles are forming and they're moving up. And what's happening is the liquid temperature is approximately equal to Tsat, and consequently the heat transfer is such that we don't lose all the energy, and then we get the vapor coming out to the surface. And on the IR camera from the top, you could see that as these splotches that would develop. And what those splotches were, those were the bubbles coming to the surface, and obviously they're quite hot because you have the vapor inside of them. Anyway, so that is the two different forms. We have pool boiling, or we can have forced convection boiling, and then we have subcooled or saturated. So what we're going to do in the next segment, we're going to take a look at the boiling curve, and this is something that is used quite often in terms of understanding what regime we're in and what types of heat fluxes we could anticipate for the boiling heat transfer processes that we might be studying. So that's where we're going.